number 49 trig unit notes. This will be the day 1. Your notes in class will be a little bit different version. Both this version and the notes we take in class will be on Canvas for you to look at. All right, the first thing I wanted us to look at right here is we're going to be looking at trigonometric functions such as sine, cosine, and tangent. And they're used to find the missing sides or angles of triangles. We will explore sine, cosine, and tangent in Math 3. All right, so you should have already seen this a little bit in Math 2. But if you look at angle A right here, and its relationship to the sides of the triangle, the hypotenuse is always across from the right angle. Always. So here, this would be the right angle, and the hypotenuse would be across from that. If you have angle A, the angle that's directly across from it, going this way, is the opposite side. So the side opposite the angle is called the opposite side. And so that has to be the hypotenuse, and that has to be the opposite side. Then you call the third side the adjacent side. So if you're looking over here, the hypotenuse has to be right here. This across from it has to be the opposite side. So if that has to be the hypotenuse and that's the opposite side, then this side has to be the adjacent. And then you have sine, cosine, and tangent. To find the sine of angle A, you use the opposite side over the hypotenuse. The opposite over the hypotenuse. To do the cosine, cosine is adjacent over hypotenuse. And then tangent is the side opposite over the adjacent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. So that's, sometimes we just write that on the paper just to remember. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So let's check it out right here. So we're going to assume this is a right triangle, and then we're going to look at angle A, and we are going to find the sine of angle A. Well, sine is opposite over hypotenuse. So for angle A, opposite is 3, the hypotenuse is 5. So this would be 3 over 5. The cosine of A is adjacent over hypotenuse. Well, if that's opposite and that's hypotenuse, that has to be adjacent. So I would say adjacent over hypotenuse, and that would be 4 over 5. The tangent of angle A is opposite over adjacent, so it would be 3 over 4. Looking at B, the hypotenuse is still 5, but the sine of B is opposite over hypotenuse, which is 4 over 5. The cosine of B, if that's opposite and that's adjacent, that's hypotenuse, then the adjacent has to be 3. So the cosine of B would be adjacent over hypotenuse, which is 3 over 5. And then the tangent of angle B is going to be opposite over adjacent, which is 4 over 3. So looking at this one, looking at angle A again, the sine of A is opposite over hypotenuse, so 5 over 13. The cosine is adjacent over hypotenuse, which is 12 over 13. And the tangent of angle A would be opposite over adjacent, which is 5 over 12. So again, what's opposite of angle A is 5. What's opposite of angle B is 12. So you can't you can't call this the opposite for the whole thing because it's only opposite of 5. Where B, what's opposite of B is side 12. 13 is the hypotenuse for all of it. So if we look at angle B, sine is opposite over hypotenuse, 12 over 13. Cosine is adjacent over hypotenuse, 5 over 13. And tangent is opposite over hypotenuse, which is 12 over 5. Okay, then the next thing is we're going to be finding Sine, cosine, and tangent for special right triangles, 30, 60, 90, and 45, 45, 90. In order to do that, we're going to come across some radicals in the denominator, and we have to be able to rationalize the denominator. Again, this is something you should have learned in Math 2, so we're going to go over the basis of it. So if you have 1 over the square root of 2, technically you should never leave a radical in the denominator. So what you want to do is multiply that by something to make it a perfect square. Well, what would make 2 a perfect square is if you multiplied it by the square root of 2, so you would get 4. Well, I can't just multiply the bottom by the square root of 2, or I'll change the whole value. But if I multiply the whole thing by the square root of 2 over square root of 2, that equals 1. I'm not changing the value, I'm just changing the look of it. So what you get is the square root of 2 over the square root of 4, which simplifies to the square root of 2 over 2. Next one, 2 over the square root of 3. Well, what do I need to multiply to make this a perfect square? Well, the first perfect square that 3 goes into is 9, so I'd multiply it by the square root of 3 over the square root of 3. And so I end up with 2 times the square root of 3 over the square root of 9, which is 2 times the square root of 3 over 3. And nothing reduces. I can't reduce that 3 with that 3 because that's in a radical. This is not, and then 2 and 3 do not reduce. Same thing here. 2 does not go into 2 because that is under a radical and this one is not. So that's important. But there's a shortcut that we can take. And basically what you can do is whatever the radical is, you're going to put it in the numerator and then just write that in the denominator without the radical. So you can skip these two parts. So you can put 1 times the square root of 2 on top and then just the 2 on the bottom. So if we had something like 2 over the square root of 6, you would rewrite it, put the square root of 6 in the numerator, and just write it as 6 in the denominator. But this will reduce. 2 goes into 6 3 times. So you get square root of 6 over 3. So let's look at another one. 7 over the square root of 10. So again, you take the square root of 10, put it in the numerator, and then rewrite it without the radical. And 7 and 10 do not reduce, so that's your answer. If you have 4 over the square root of 5, you would end up with 4 square root of 5 over 5, and that does not reduce. So that's just a simple way of rationalizing the denominator. If this ends up needing to be reduced, then that's a whole nother issue, but this is just a fast, simple way of rationalizing the denominator. Multiply the numerator by whatever the radical was in the denominator, and then rewrite it without the radical. All right, so let's look at A here. A is 30 degrees here. So what we're going to do is we are going to, sine is opposite over hypotenuse. So this would be 1 over 2, which is 0.5. And I want to put it in that form so this makes sense to you in a second. Cosine would be adjacent over hypotenuse. Square root of 3 over 2. Square root of 3 divided by 2 in your calculator is approximately 0.87. And then the tangent of A would be opposite over adjacent, which is 1 over the square root of 3. See that? We'd have to rationalize the denominator, multiply the top by square root of 3, and then rewrite the denominator without the radical. So it's just the square root of 3 over 3. If I put that in my calculator, it's approximately 0.58. All right, so to do that in the calculator, I'll show you on this. First thing you do is you would want to go to your mode and make sure it's in degrees. Usually it starts right here in radians. You want it in degrees. So you're going to arrow over and you're going to hit enter so it'll be on degrees. All right, on your Chromebooks, if you go to the graphing calculator, and if I go to mode, I already changed it on this one, but you'll have to arrow down with your keypad. And normally it'll be on radian, it'll be right there. So normally radian will be highlighted. So just arrow over, arrow down, arrow over, and then hit enter so it's highlighted. So what I wanted to show you now, so I can hit clear, is I wanted to find the sine of 30. So I would hit sine of 30 in my calculator, and it is 0.5. So this is, look right here, this is, the sine of 30 is 0.5, which is what we thought it was going to be. Now let's try the cosine of 30. The cosine of 30 is approximately 0.87. Well, that's what we thought it was going to be. So 0.87, and then the tangent of 30 degrees is approximately 0.58. So approximately 0.58. These are approximates. All right, so you can do that with your graphing calculator on your Chromebooks. Okay, so what I want you to see here is these are the exact values. These are the exact values, and these are the rounded values. So I wanted you to see that they are the same. So this is a special right triangle, 30, 60, 90, and we can find sine, cosine, and tangent without ever even using a calculator. And these are our exact values right here. Down here, if we look at B, 60 degrees, so sine is opposite over hypotenuse, which is a square root of 3 over 2, which we know is approximately 0.87. The cosine of B is going to be adjacent over hypotenuse, 1/2, which is 0.5. And the tangent of B is the square root of 3 over 1, or just the square root of 3. And if you just put the square root of 3 in your calculator, it's approximately 1.73. So on my calculator, make sure you hit enter once it's highlighted. You would do the sine of 60. See, it's approximately 0.87. The cosine of 60 is actually equals 0.5, and then the tangent of 60 is approximately 1.73. So again, we get the same thing. These are exact answers right here, and these are rounded answers. So you can always check yourself with your calculator. Just make sure the mode is in degree. When you clear a calculator, the mode will always, again, here, when you clear a calculator and you go to mode, it will always be on radian. So you have to arrow down and hit enter to get it on degree. All right, so 45, 45, 90. Let's look at this one. Again, the sine of 45, the sine of angle A, it will be 1 over the square root of 2. 1 over square root of 2 rationalized is the square root of 2 over 2. That is approximately 0.71. The cosine is adjacent over hypotenuse, which is the same thing. And you get the square root of 2 over 2, which is approximately 0.71. And the tangent is adjacent over hypotenuse, which is 1 over 1, which is 1. So in the calculator, if I put sine of 45, I get approximately 0.71. The cosine of 45, approximately 0.71. And then the tangent of 45 equals 1. So we get the same thing. Again, these are exact answers. These are approximate answers. So we always have to be able to find exact answers. Okay, now we're going to look at the unit circle. There's a couple of things on the unit circle that you need to understand. One thing to remember on the unit circle is the radius is always 1. The radius is always 1. So on the unit circle, the radius equals 1. Well, you still have your quadrants. Quadrant 1, 2, 3, and 4, just as normal. And then in quadrant 1, the signs are all positive, positive. In quadrant 2, x's are negative, y's are positive. In quadrant 3, x's are negative, y's are negative. And in quadrant 4, x's are positive and y's are negative. So that stuff we should already know. But now we're going to look at radians. And most of us already know like degrees, like 0 degrees, 45 degrees, 90 degrees, 135, 180. So degrees make sense to us because that's what we learn. However, we need to understand radians too. So, for example, this is 0 degrees. 90 degrees is the same thing as pi over 2. And then 180 degrees is the same thing as pi. Well, we know pi is 3.14. So where does this come from? So let me show you where this comes from. If we go to this website right here. So if we go to this website, and so let me start it over. All right, well, it's going to start over right now. So watch what happens. So that's 1 radian, and then you have, that's 2 radians. So all the way around 360 is 2 pi. So here's where it comes from. On the unit circle, the radius is 1. So they're going to show you that right now. On the unit circle, the radius is 1. So this is r. The radius is 1. So this is with any circle. If you take that radius and kind of lay it on the circle starting at 0, you'll have 1 radian, and then 2, and then 3, and then see that? That's that where that 1.4 comes from. That's that section. So that's at 3.14. So that's 3.14, and that's 1 radian. So we call that pi, and then all the way around again would be 2 pi. So there are other portions of pi along the way. So that's where that comes from. Whatever the radius is, if it's 3 inches, then you'd have 1, 2, 3, and then 0.014 on and on, the rest of pi. So that's where it comes from. So we have to understand what the radians are. And so in class, what I'll go through and what we did go through was if this is 0 and this is 1 radian. So 1 radian is 3.14. So 180 degrees is pi. So if we go by 45s, 0, 45, 90, 135, 180, then those are broken up into quarters. So you have 1/4 pi is 45 degrees, 2/4 pi, which reduces to pi over 2, is 90 degrees, 3/4 pi is 135 degrees, and then this is 4/4 pi, which is 0 to, which is the same thing as just pi, it reduces. So again, this is 1/4, 2/4, which reduces, 3/4, and then 4/4, which reduces to pi. And then so now you're going down another quarter, so that's 5/4. And then 6/4 reduces to 3/4 pi, 7/4, and then 8/4 reduces to 2 pi. So this is going by 45s. If you cut it into, if you cut pi into quarters, 45, 90, 135, 180. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. And then just make sure you reduce your fraction. 2/4 reduces to pi over 2, 4/4 reduces to pi, 6/4 reduces to 3 pi over 2, and 8/4 reduces to 2 pi. So that's that. Now, to get the rest of them, because we're going to be finding all of the 45 degrees and all the 30 degrees. So on this one, it goes by 30 degrees. So 30 degrees, from here over, that is pi. 30 degrees cuts it into 1, 2, 3, 4, 5, 6 parts. So 30 degrees would be one of the 6 parts. 60 degrees is 2 of the 6 parts, which reduces to pi over 3. 90 degrees is 3 out of the 6, or pi over 2. 220, so 90 degrees plus 30 is 120. And then that would be 4 out of the 6, which is 2 pi over 3. Plus 30 degrees more at 150 is 6 pi over 6. And then 30 degrees more at 180 is 6 pi over 6. This was 5 pi over 6. This is 6 pi over 6. So what is it? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. And then again, always reduce your fractions. This one reduces to 1 pi over 3, 1 pi over 2, 2 pi over 3, and then 6 pi over 6 reduces just to pi. So then you keep going. This one would be, if that's 6 pi over 6, that's 7 pi over 6, which doesn't reduce. 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6, which reduces to 3 pi over 2. 10 pi over 6, which reduces to 5 pi over 6. 11 pi over 6. And then 12 pi over 6 reduces to 2 pi. So without reducing, this is 1 pi, 1 6 pi, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6, 8 6, 9 6, 10 6, 11 6, and then 12 pi over 6. And then again, if they reduce, you have to reduce them. So it's easy to find them. So the 30 degrees would be divided into parts of 6, and then the 45 degrees are divided into fourths. 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, 8 fourths. All right, and then here it is all together. Here is your degree, and then here are your radians. And then you see these coordinates? Well, where these coordinates come from, and eventually you'll be able to memorize them. And actually, there are the same exact coordinates. These 3 coordinates are repeated here, here, and here, and the only difference is the sign. So look, 30 degrees up, 3 pi over 2, 1/2. This is still 3 pi over 2, 1/2, except my x is a negative 3 pi over 2. Because in the second quadrant, these are negative and positive. 30 degrees down, 30 degrees down, it's still square root of 3 over 2 and 1/2. It's just in the third quadrant, they're both negative. And in the fourth quadrant, it's positive, negative. So as soon as we memorize these 3 coordinates, then we know them all. So we're going to be working on that. All right. So we'll concentrate only in quadrant 1 tonight. If you know quadrant 1, then you can get all the rest by knowing what signs go in each quadrant. So here's what's going on with that. So if we know the radius has to be 1, the radius has to be 1. So if this was 30 degrees, if this one is 30 degrees right here, this is 30 degrees, then this x value would be, if you measured it, it would be square root of 3 over 2, and it would be going up 1/2. So if this is 0 to 1, if I went over here, that's half of it. If this is 0 to 1, this would be half. This would be square root of 2 over 2, and this would be square root of 3 over 2. So the coordinate for 30 degrees, the x value is square root of 3 over 2, and the y value is 1/2. So that's the coordinate for that one. If we go 45 degrees, then what happens is if this is 0 to 1, then this length would be square root of 2 over 2, and this height would actually be square root of 2 over 2. So the coordinates for 45 degrees would be square root of 2 over 2, square root of 2 over 2. And then if you go 60 degrees, this is going over half, so that's halfway between 0 and 1, so this is the half. So this section right here is a half, and this section right here is square root of 3 over 2. Square root of 3 over 2. All right, so then what you have is all of them together. Oh, so this one, your x value is 1/2, and then you have square root of 3 over 2. All right, so 0 degrees, so you have 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. This coordinate right here would be 1, 0. That's your x and y. This coordinate right here, your it'd be 0, 1. 0, 1. All right, so something I want you to make sure that you need to make sure you understand this, is that you would have 1, I'll do it in pencil. you would have 1. And then square root of 3 over 2 is approximately 0.87. Square root of 2 over 2 is approximately 0.71. And then 1/2 obviously is 0.5, and then you would have 0. So they're going to go in order. 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. So 0, 0.5, 0.7, 0.87 or 0.9, and then 1. So they're going to go in order. So here they are all together. I'm going to write them down, and then I'm going to show you the pattern. So this one was, again, 1/2 and square root of 3 over 2. This one was square root of 2 over 2 and square root of 2 over 2. And then this one is square root of 3 over 2 and then 1/2. Okay, so I want you to notice all of the denominators here are 2. All of the denominators are 2. That's the first thing. And then it goes in order. So if you look at the x values, you can come up here. You can go 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. It goes in order of how big they are. And then 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. So you can go down for the x's and up for the y's. So basically it's this: 0, 1, 2, 3. 0, square root of 1 is 1, square root of 2, square root of 3. And then you go backwards. 0, square root of 1 is 1, square root of 2, square root of 3. So you're going down one side and then you're going backwards on the other. 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. So we'll keep working on that, and you'll need to memorize that. All right. And then what you have is, all right, the other thing you should know is this. Your x and y is cosine and sine. So cosine of the angle is x, the x coordinate. Sine of the angle is the y coordinate. Tangent of the angle is y over x. Oops. Tangent of the angle is y over x. So what would happen is, just to show you, right here, if I did the cosine, let's say the sine of 60 degrees, the sine of 60 degrees would be, look, that's the hypotenuse right there. That's the hypotenuse. So the sine of 60 would be, this would be 1. It would be the square root of 3 over 2 over 1. The square root of 3 over 2 over 1. So the square root of 3 over 2. And then that's the sine of 60. But what actually is that? That's actually the y value. I'm sorry. Yes, the y value. Sine is the y value. My brain went bad a second. So sine is the y value. So this equals the y value. If I look at the cosine of 60, the cosine of 60 is adjacent over hypotenuse. So 1/2 over 1. So that would be 1/2. And then what is that? That's the x value. That is the x value. And then the tangent of 60. What is tangent? It's opposite over adjacent. So if I said the square root of 3 over 2 divided by 1/2, the square root of 3 over 2 divided by 1/2. Remember, we do not divide fractions. We multiply by the reciprocal, and that would just be the square root of 3. All right? Well, that's the same thing as saying y divided by x, y divided by x, y divided by x. That's exactly what we just did, y divided by x. So this is the same thing as y divided by x. So they all have a relationship here. So the same thing up here, just really quick, if I was to say the cosine of 30, if this is your right angle and that's 1, the cosine would be opposite over hypotenuse, which is 1/2 over 1 or 1/2. Well, cosine is the oh no, my bad. Cosine is adjacent over hypotenuse. Square root of 3 over 2. I knew something was wrong. So cosine is adjacent over hypotenuse. Square root of 3 over 1. Square root of 3 over 2 over 1. Adjacent over hypotenuse. And cosine is the x value. Sine of 30 is opposite over hypotenuse, so 1/2 over 1. And sine is the y value. And then tangent of 30 is opposite over adjacent, so it would be 1/2 divided by square root of 3 over 2, which is 1/2 times 2 over the square root of 3, which is 1 over the square root of 3, which rationalizes to the square root of 3 over 3. And I literally just did y over x. Y divided by x. Y divided by x. And I end up with that same thing. So again, cosine is whatever the x value is on the coordinate. Sine is whatever the y value is on the coordinate. And tangent would be the y coordinate divided by the x coordinate. So this is something that you definitely need to know. All right, so for your homework,